All right, yo, what up, everybody? Today we're going to be talking about Newton's second law and specifically what happens if you have multiple forces. So, what if there's more than one force on an object? And so, we'll start with this example. There's a 5 kilogram object, it has 30 newtons of force pushing it up and 80 newtons of force pushing it down. So, what's the acceleration going to be for this object? Well, remember with Newton's second law, we're looking for the net force, right? So, it's not just one of the individual forces, it's the combined effect of the forces. So we have to look at the two forces we have, and we have a bigger force down than we do going up. And so this thing's going to be pushed down. You can think of it this way. The 80 Newton force on the bottom, 30 Newtons of that force is going to be taken up, canceling out this force on the top. Then the remaining 50 is going to be your net force. That's what you have left over. All right, so really what we did is we just did 80 minus 30 to find the net force. And then we put 5 in for the mass. And that gives us that right there. Divide by 5, and you get an acceleration of 10. And that acceleration would be in the downward direction, because that's the direction the net force is in. Now, what if the forces are on the same side? In this case, they're both pushing the box in the same direction, so we're going to add them together to get the net force. So 80 plus 30 is 110. Put in 5 for the mass again. Divide by that to cancel it out, and you get an acceleration of 22 meters per second squared. And this would be an upward acceleration. As you see, the net force is pointing upward. Here's another example. All right, so let's say we know the forces on the box. We know the acceleration is going to be 5 meters per second to the right. Now, what's the mass of the box? All right, so we can also solve this one. So first of all, what force do we put in for the F net here? You notice there's more force to the right than to the left. So you do 25, force here minus 5. And you get 20. And then you have 5 for the acceleration. And so the one that you don't know is the mass. So we'll just divide by 5 so we can cancel out the 5 on that side. And 20 divided by 5 is 4. So the mass of the object must be 4 kilograms. All right, let's say we know the mass. We know how fast it's accelerating. Accelerating 4 meters per second squared to the right. And we know that there's like some force trying to slow it down here. And then there's a force speeding it up on this side. So how big is the force that's speeding it up? Well, we'll put in the numbers. All right, the net force is going to be whatever this force is on the right minus the force on the left. That's equal to mass times acceleration, which we know are 45 and 4. So we can multiply those together to get 180. Now, using a little bit of algebra, we'll just add 100 to both sides. That gives us 280. All right, and so we just solve for the force on the right would have to be 280 newtons in order to accelerate this box at this speed. All right. Now, in our next video, we'll discuss what happens if you have forces in different dimensions. So what if you have horizontal forces and vertical forces acting on the same time? All right. And so if you need to learn that, we'll see you all in the next video.